Welcome to the seventh session of the module 4. In this module we are going to discuss about the tidal energy. The tidal energy, or what we call it as the ocean energy. Basically this tidal energy is from the bulge on the side towards the moon is responsible for one tide, but the effect of centrifugal force is responsible for the bulge on the other side. So this is the reason why this tides have been caused. Basically these before I just explain you why these tides have been caused. Basically this tidal energy are a periodic rise and fall of water level of a sea, which are caused by the action of sun and moon on the water on the earth. Actually basically it will be the relation, the influence of sun and moon on the earth. It causes predominantly, since the most part of the earth is been covered by the water, so it affects more onto the water. That is the reason why the sea water periodically rises and falls. So that is what we just call it as the tides. They are mainly caused by the gravitational force of attraction of the moon and the sun on the water or on the earth. 70% of the tides have been produced by the force due to the moon, and 30% it is due to the gravitational force of attraction due to the sun. As we know, the direction of rotation of the earth and the moon, it is always same. That is the reason why we always see only one face of the moon. It is only because the direction of rotation of both moon and earth, it is the same. Is it clear? There are two tidal cycles and one tidal cycle. That is how we say it as it. If we consider the two tidal cycles, they occur during the lunar day of 24 hours and 50 minutes. There are two high tides and two low tides. Time between high tides and low tides at any given location is little over 6 hours. As the high tide will be experienced at a point which is directly under the moon, at the same time the diametrically opposite point of the earth's surface also experience a high tide due to the dynamic balancing. Hence the full moon, that is the full moon where we can see the complete moon circularly, whereas no moon, that is just opposite. Full moon and no new moon produces a high tide. The rise and fall of water level always follows sinusoidally. It is something like a sinusoidally, it rises and it just falls out here. So the high tide and low tide, this is what we just mean to say. That is the reason why you might have experienced it practically during the new moon time, or it may be a full moon time. The intensity with the tides that you see it in the coastal places will be more severe compared to the other days. It is only because of the gravitational force of attraction will be predominant between the moon and the earth. Okay, now when this water is above the mean level, it is called as a flood tide, and when the level is below the mean level, then we call it as a ebb tide. So when it is above the sea level, then we call it as a flood tide, and when it is below, then we call it as a ebb tide. So only it is also called as a ebb tidal energy harnessing also we sometimes we call it. These tides can be used, basically these both ebb and the flood tides can be used to produce the electrical power, which is known as the tidal power. So what happens, basically the rise and fall will be a sequential one. That will be a sequential one which rises and which falls down. So that is what, before I just explain you the basic principle, let me take a small example. If you can see this, if you are in the coastal region, you can make a mark on the 15 days once we will always get a new moon, and after the 15 days we will get a new moon. On the first day, soon after the new moon, you can make a point where the tides have been reached. So as it keeps progressing, at the middle of the 7th or 8th day, it will be a minimum, and after the minimum, that is after the 7th or 8th day, it keeps increasing. It keeps increasing. Whenever these tides have reaches the higher than the sea level, then we call it as the flood tides, which will be on the superior sinusoidally. And once it rises, obviously it has to move downwards, and that's what we call it as an ebb tide. And this movement that we are going to harness it for the electrical energy generations. Because of varying at ocean depths, land masses and other factors at different locations on earth, the actual tides are also vary. My dear friends, basically what happens is, we have never, it is very complicated one. We cannot really make out what are the different depths in the sea. Certain occasions when you go for a deeper sea, we get around kilometers together, the depth, and this depth cannot be imagined or it cannot be assumed. Because of the variation in these sections, what happens, there will be a different variations in the tides also causes. Is that clear? So soon after that, when the sun and moon and earth all align, a stronger gravitational pull occurs on the oceans. The sun, moon and then earth, when these align, then there occurs a gravitational pull occurs on the oceans, and higher and lower tides called as the spring tides are produced. The spring tide has nothing to do with the spring season of the year. Spring tide is different than the spring of the year. Rather, it occurs at a new moon and again at a full moon. That is what new moon and full moon, approximately twice a month it just occurs. The first and the third quarter, the net gravitational force of the sun and moon is not as pronounced, so lesser tides than normal called neap tides are also called as the ebb tides are produced. The neap tides also occurs twice each month. The currents associated with the tides depend on the particular location on the earth. Currents from tides can vary from 0 to 2 meters per second. 2 meters per second means basically it just comes around 8 kilometers per hour. That is the speed with which it just comes out. Basically, this tidal barrage, how does this tidal barrage comes work out? A tidal barrage is also nothing but a dam. A dam or a tidal barrage which has been constructed in such a way that the basin or the place where it is been collected, that is what we call it as a basin. The dam or a barrage, it has been constructed in such a way that the basin gets separated from the sea, and a difference in the water level is obtained between the basin and the sea. The constructed basin is filled during high tide and emptied during the low tide passing. So the sluice gates. Sluice gates, usually even we use it in our regular dams also, where the water is been allowed to flow through. For the complete dam, it will not be open. Only through the sluice gates the water is been allowed to move. This particularly makes the water to move with certain velocity, because all the potential energy with its height has been collected and it has to be channelized to move in one particular gate. That is what we call it as a sluice gates. The constructed basin filled with the high tide will be made to pass through one particular sluice gates, and the turbine will be fixed around this the sluice gates, so which turn then the potential energy of the water stored in the basin will be used to drive these turbines, which in turn generates the electricity, as it is directly coupled to an alternator or a generator which generates an electricity. Basically, these components will have three main components in the tidal power plant. One is the dam, or whatever we call it as a barrage, and then the sluice gates, and then we will have a powerhouse. So basically, this tidal barrage system is designed to convert tidal power into electricity by trapping water behind a dam called as a tidal barrage dam. Basically, just would like to show you here. Now, this is one. Okay. Now, this is a single basin and this is a double basin. Now, let me talk about a single basin. Now, the tides of the spring tide, and then we also called it as, the other one is the spring tides, that is are the flood tides, what we call it as, and then we call it as the neap tides. Spring tides and the neap tides. See, spring tides are also called as the flood tides, and the neap tides are also called as ebb. So ebb or neap, what happens is, the flood tides, when it is being caused when the gravitational pull or the gravitational force action is more, then the pulling force will be more. This pulling action, gravitational pull, makes the water to go above the sea level. That makes it a sinusoidally upper rise. So this, on these occasions, what it is being done is, as you can see, this S is a sluice gate. Okay, now at this height, what we will do it is, we will keep the water to move to this basin. This is something like a catchment area where the water will be stored with a higher potential, and this is being caused only during the flood tides or the spring tides. So it will come and collect over here with certain height. So this is what is this hatched position, which is called as the dam or a barrage. So the water will move here, and then the gate will be closed. Then after the flood tides or the spring tides, what happens? There will be a neap tide or a ebb tide. So whenever this ebb tide occurs, it will be below the sea level. That means we have a water at this height, and there is a ebb tide has occurred at this position in the ocean. So what happens? Automatically the water can be allowed to flow through it. So what we will do it is, we will allow the water to flow back to the ocean with the ebb tide through the turbines over here. So that what happens? This water will be moving with the 2 meters per second or 8 kilometers per hour, makes this turbine blades to rotate. These turbines will be connected to the generator, which generates the electricity. Now I'll get back to you. Now you got an idea what do you mean by tidal barrages. Now here also there is a barrage. So let me talk about this barrage. So tidal energy, the tidal barrage and generates power from a tidal barrage system is designed to convert a tidal power into electricity by trapping water behind a dam called as a tidal barrage dam, and generating power from the inflow and or release of water. The tidal barrage dam is a large dam that stretches completely across the estuary, harbor or river that connects to part of the ocean that has a tide. When the tide rises, the sluice gates open and allow the tide to flow through the tunnels and fill the area behind the dam. Okay, when the water is flowing into the area behind the dam, as the tide is rising, it causes the turbines to rotate and produce electricity. When the tide reaches its highest level and gates closes, capturing the maximum amount of water behind the dam will also makes the store of energy in terms of tidal energy. Okay, now when the tide drops, it creates a difference between the water behind the dam and the water in front of the dam, that is at the level of low tide, or we call it as an ebb tide or a neap tide. Okay, when this difference is large enough, the flow valves are opened so that the water flows under the dam through the tubes and past the generator turbine, causing it to turn and produce the power. This is what we have discussed. Now what happens, even this dam or the barrage or a similar word. The function of the dam or a barrage, it is the same thing. But what happens is the basin or between one basin and the other basin, in case of multiple basin, it can be one basin or two basin also. Tidal energy barrages have to resist waves whose shock can be severe and where the pressure changes sides continuously. The barrage needs to provide channels for the turbines in reinforced concrete or reinforced material. The location of the barrage is important because of the energy which is being available is related to the size of the trapped basin. If you trap it, if the water which doesn't possess the highest potential energy, then the point of storing this water will not be useful. That is the reason why the place where we are going to place it is very important one. The nearer it is built to the mouth of the bay or the larger the basin, but the smaller the tidal range, a balance must also to struck between the increased output and the increased material requirements. And the construction cost tidal barrages requires sites where there is sufficiently high tide range to give a good head or a potential energy of water, and the minimum useful range is around 3 meters. Within that it has to be. And the second most important part of the tidal energy is the sluice gates, or what we call it as the gates and the locks. The sluice ways are something like in one way or the gates that you might have come across in regular dams, where it just prevents the movement of the water. Okay, the sluice ways are used either to fill the basin during the high tide or to make the empty during the other in the front rows, vice versa. Okay, it will be used to empty the basin during the low tide as per the operational requirements. These gates structures can be floated as a modular units, though the existing plants vertical lift gates have been used. It just lifts out, like as I just told you, it is something like what we use it in our conventional dams. And the technology is about the ready to substitute a series of flap gates, and these flap gates are gates operated by water pressure that are positioned so as to allow the water to holding the basin and require no mechanical means of operation. These flap gates, something like this, a flap gates only in direction of the sea to basin, hence the basin level rises well above the sea level, as the ebb flow area is the far less than the flood flow areas. So what they will do is they will have a controller system which automatically controls the movement, and it opens like a flap gate. And then we will have a powerhouse or the turbine with electric generators and other auxiliary equipments are the main components of this powerhouse. For small head and large size turbines are needed, hence the powerhouse is also large structure. Both the in both the cases, whether it is a flood tide or a spring tide or even in the ebb tides, in both the cases we can make the tidal energy to generate the power. Here the powerhouse plays a very major role compared to the wind energy. It is only because in the wind energy what happens, there is no water is coming into picture. We can keep it in a nacelles and it will be sealed so that the water doesn't enter. Now this is a sea water which will be exposed to this power sector, has to be very need to be maintained very carefully. Okay, and this tidal power plants can also be classified into different types. One is a single basin and the other is double basin. That we can see it over here. As I have already explained to the single basin how does it work, let me look into the double basin, where this double basin will have a multiple ways by which the electricity can be generated. That means in both the occasions of the movement of the tides, energy can be utilized. Now here, if you see this, the leftmost part is nothing but the sea. Whenever there is a high tides or the flood tides or the spring tides are there, so this particular sluice gate will be open. So whatever the energy that is being there will be stored in the upper basin. In the upper basin, it will have a very high, it is something like a dam, wherein which the highest water with the higher potential energy at the head, it will be collected over there, and then the gate will be closed. Then what happens, this upper basin, from the upper basin where the water is being collected with certain height which possess the more potential energy, will be allowed to pass through the lower basin which is adjacent to that. During this, what happens, the water which is flowing with certain potential energy will also carries out some pressure, that is what will be converted into kinetic energy. Thus potential energy will be converted into the kinetic energy of the water, and then that will be used to run these generators which produces electrical energy. Then it will be during the low tide, what happens, it will be sent back to the outlet of the sluice gate. This is an inlet sluice gate and this is the outlet sluice gate. So this is how it is, something like a circularly from high tide to the upper basin, from the upper basin to the low tide, lower basin, from the lower basin to the lower tide, once again upper tide, the higher tide to the upper basin to the lower basin, and lower basin to the low tide, from low tide to the once again high tide. So this is how it circularly, cyclically it just happens. So however, it will be repeating in 15 days once. So 15 days once we will be getting a very high tides. What are the advantages and disadvantages? Generating electric power from the basically, actually, before we just talked about this, in the double basin, what happens, the major thing is the turbine is set up between two basins, that is between the lower upper basin and lower basin. One basin is intermittently filled by the flood tide and the other is intermittently drained by the ebb tide. Therefore, the small capacity but continuous to power is made available with the system as it will be separated in a cyclic process. The main advantage of this system is that 50% of the potential energy is sacrificed in introducing the variation in the water level of the two basins. Is it clear? In case of this off-peak power from the basin, from the base load plant, the interconnected transmission system is used either to pump the water by the high basin or net energy gain. It is also possible with such a system if the pumping head is lower than the basin to basin turbine generating head. There are many advantages of this double basin. With the single basin, it is the continuous energy can be utilized. They are the few of the advantage of this double basin actually, but it will also have certain disadvantage where whenever there is a variation due to climatic changes, it is difficult to manage. Okay, let me look over the advantages of tidal energy. Generating electric power from the tidal energy has got its own advantages and limitations. One of the biggest advantage of the tidal energy is that the tides are practicable, they are predictable and occur all along the ocean front. However, the current is not constant but fluctuates as tides move in and out. This is what it is. So it is only because, as I have already told you, the tides which are coming to the shore are along the coastal places where they are predictable and all occur along the ocean front or the shore end. However, the current is not constant, it just keeps varying, and it will be constant. That is important. Have you ever seen tides not coming to the ocean front? It does comes. The location of the turbines underwater is an advantage because it eliminates noise and large visual presence. obviously even we will not to come to know whether the turbine has been placed or not, because it will be submerged inside the water, so that we will not be able to see it also. And major advantages, general advantages, what we can make it out, it is free from the pollution, as we know it. Even the wind energy is also free from the pollution, and it does not use any fuel, and hence it doesn't make any pollution also. Obviously the tides are totally independent on nature's cycle of rainfall. Whether it rains or not doesn't matter. Throughout the 365 days, lunar new moon and full moon is meant to occur. There is no variations. Is it clear? What happens in a wind turbines? So the wind flow keeps varying for all the 365 days, correct? So what happens in this tidal energy? The tides energy formations, the tides formation is regular for all the 15 days. Okay, so 365 days we can expect the full moon and new moon, isn't it? So this will also not produce any unhealthy waste like gases, ash, atomic refuses, which entails with a heavy removal cost. Obviously when we are not using anything which are combustible, so it doesn't make any sense in finding out ash or gases. So another notable one of the advantage is that the tidal power is that it has a unique capacity. It has a unique capacity to meet the peak power demand effectively when it works in combination with thermal and hydroelectric systems. But still, it has got its own disadvantages. One of the major disadvantages, the efficiency of converting is less. Efficiency of converting this tidal energy into electrical energy is less. And few other advantages: initial expense of installation and upkeep of marine system located in salt water is highly difficult. Now my dear friends, even if we go and play it in a sea water for 1 hour, we feel so uncomfortable. You just imagine the materials handling under the water is not a joke, because they will be exposed to 24/7. They will be exposed to a completely a saline water, or like something like a brine solution. So the replacement or the maintenance of these materials which are being used is the biggest problem. That is the reason why people are going with higher marine salt resistance corrosion coatings, but still they could not meet it. And not only that, it also concerns includes the effects of any system on the marine life. It may be a fish or seals or marine life, and other birds will be affected majorly because of this tidal power plants. A concern for barrage dams is the effect on fish migration patterns as well as fish mortality due to passing through the turbines also reduces. That is the major disadvantages of this. In addition, we can also say these power plants can be developed only if the natural sites are available. We cannot make our own sites. Say for example basins, we cannot make it on our own. Even these conventional dams, how they will construct? Do they create a mountains, then they make the dams? No, not at all. They will search for the site, they will search for the locations. Civil people must be knowing it better. They will check out the catchment area, they will check the availability of water and the availability of natural resources where it is more suitable. In most of the occasions, it is always built where the catchment area is more. Catchment area means the water which can be stored, and they will always see the hill stations. Natural catchment area they want it. Is it clear? And they will always see the hills. In between that, they will prefer to construct the dam so that it resists the flow of water and restricts and stores it. So likewise, even these tidal power plants are always preferred to store it in a natural site. They cannot make it on their own. These power plants will be always located far away from the load centers. The power generated must be transported to a longer distance. Say for example, we are just generating the energy at the level of in the ocean, that has to be transmitted. That is one of the biggest challenge, because the climatical environmentally also it doesn't support us, because lot of wind flows will also be there, tides will also be there, so it is a greater challenge. This increases the transportation cost also will be more. The capital cost of the plant is more considerably with any other conventional thermal power plants. That is the reason why people doesn't go. Whatever we generate electricity should be costless. Say for example, if you are paying 500 rupees every month for the electricity bill, the same electricity we will take it from Tidal Energy where we have to give 1500 rupees. Who will go for that? Obviously we will go for the lower one. So the cost is more. That is a major disadvantage. The supply of power is not continuous as it depends upon the timings of the tide. Therefore some arrangements, that is the double basin, we go for multiple basins and pump storages must be made to supply the continuous power. This also further increases the capital cost of the plant. It is very interesting to observe that tidal power plants varies with the lunar cycles, because the moon largely influences on tidal rhythms where there are our daily power requirement is there is continuous, whereas this varies with day to day. And more important is, even if in case of the maintenance it is very difficult, you have to go underneath of water and then we have to maintain it. So that is all will be incurred in the cost of the electricity generations. Another concern is changing pattern for the sediments. Sediments, that is what I am just talking about. Sediments are the collections continuously, which is very difficult to remove it, because it is a salt water. When water containing sediments flows, the sediments that are suspended in the water tend to be deposited. So it just keeps depositing it, the salt. So it has to be removed often. The world's largest tidal power systems, the Sichuan Lake Tidal Power Station, is located in North Korea. This system, which opened in 2011, is of a capacity of 254 megawatts. Tidal Barrage Dam, west of Seoul, South Korea. This is one which is a famous one with the maximum power generation with respect to that. A problem with this method of generating power is that it depends on the height in the barrage, which drops dramatically when it is supplying energy as opposed to a large reservoir where the level is much less variable. This is the one. Okay. Now in the next class we shall talk about the other part of this tidal energy, that is the wave energy.